Hi everyone, this is Preeth and this is the first video from Advanced Networking BGP series. On behalf of entire HCL family, I would like to welcome you to this series. And I'm giving an assurance that we are going to discuss something big today. B for big and B for BGP. Let's jump in. So what is BGP? So BGP is a border gateway protocol, and it is a protocol of internet. So Preeth, are you saying that eIGRP is not a routing protocol of internet? And are you saying that OSPF and RRP is not routing protocol of internet? So wait. Don't come for a fight. Let me tell you, BGP is a routing protocol of internet, and it is a exterior gateway protocol. Exterior gateway protocol. What is that? So I'm saying we all know different kind of dynamic routing protocols. All these dynamic routing protocols we divided into two. One is IGP, that is interior gateway protocol, and next one is EGP, that is exterior gateway protocol. So what is the difference between these two? So IGP, all these RIP, OSPF, eIGRP and all coming under this umbrella, that is IGP. And exterior gateway protocol, there is only one protocol under that, that is BGP. So what is the difference between these two? And I can say, we all know about how an enterprise network is working. We have multiple routers, all routers are connecting each other and sharing dynamic routings, and at last it is connected to ISP. So we all know how a packet traveling up to an ISP. It's because of some dynamic routing protocols, and that all dynamic routing protocol I can say that is IGP, that is interior gateway protocols. And beyond that, what is happening? And what exactly happening in an ISP environment? ISP cannot use OSPF, RIP or eIGRP as a dynamic routing protocol for sharing their entire network. So in those cases, they are using a protocol that is BGP. And that protocol is coming under exterior gateway protocol. So two things, one is interior gateway protocol and another one is exterior gateway protocol. This is how a normal enterprise network as I discussed. So here we have multiple routes. All these routes connected each other, and it is finding out the best way because of the dynamic routing protocols. One can be OSPF or another can be eIGRP or RIP. It is finding the best way, and RIP routes can be shared to OSPF because of route redistribution, and same for OSPF. OSPF route can able to share to RIP because of route redistribution. All these are connected to ISP, and we are going to discuss in this case of BGP not what is happening in enterprise level of network, and we are going to discuss about what is happening in ISP level of internet. So this is what I am saying, routing protocol of internet, and it is sharing routes through autonomous systems instead of routers. So what is that? So last case we all know these two OSPF routers are connected each other and making a neighbor relationship between each other and sharing routes. Actually, route sharing happening in between two routers because of this dynamic routing protocol OSPF. BGP is not sharing routes in between routers, and it is sharing routes in between autonomous systems. So what is autonomous systems? Autonomous system is one or more network under one authority of an entity. That is known as autonomous systems. So let's take this example. So we have different ISPs. These all are ISPs network. And we have an ISP, the autonomous system 2341, and another ISP autonomous system 100, another 43, and 332 on 444. And all these ISPs are connected to one or more ISPs. So how the network is communicating? And this is my PC, and my PC is connected to my end router, and this router is connected to ISP routers. And normally in this case, we will create some policies, we will do NATing, we will do ACL, and we will filter some traffic, and it is going to ISP. Correct? It is going to ISP. And in this case, if we are communicating or if we are pinging from this PC to Google, what is exactly happening? So that's what we are going to discuss here. The packet will travel from this PC, my test PCs, to WAN router, and from this WAN router to ISP, and ISP have public IP address series. I can say 34 series is my public IP address, and that series is mapped to a unique autonomous system number, and the similar case for all the ISPs. And I know google.com is connected to 444 autonomous systems, and which they have a public IP address series 21.x.x.x. So these all autonomous systems are sharing routes in between. That means autonomous system 332 will share routes to 43, telling that I have 191.34 series, and this will share an information that I have 1.2 series. And I am trying to connect to google.com. Using DNS, I know that it is 21 series, and it is connected to ISP, and ISP knows that 21 series means it is connected to autonomous system 444. And then it is checking how to reach 444 easily. Can I go through this way? Yes, you can. Can I go through this way? You can. Can I go through autonomous system 100, 43, 332 and 444? Yes, you can. And how the calculation, how it is finding the best way, it's only because of the EGP routing protocol, that is BGP. That is Border Gateway Routing Protocol. And it is totally independent of how my bandwidth is, or it is totally independent of how much capable of my router is. And it is totally dependent on how many autonomous systems away is my network. It is some kind of advanced fancy of number of hops, hop count, right? How many hops away is my network? I heard this somewhere. Yes, you use this in RIP. RIP metric calculation is on hop count. And it is a fancy way, advanced fancy way. That is, BGP will use how many autonomous system number away is my network. So that calculations will happen in BGP metric calculation. And it is the slowest routing protocol. So we all are discussing about internet, and you are saying that this is the slowest routing protocol. How it's matching? So let me tell you, if it is a EIGRP or if it is a OSPF, what will happen? There are two routers connected and two routers having a neighbor relationship, and every time, every seconds or millisecond, number of packets will send for checking whether it is alive or not. In case one network went down, or in case of link failure, it will do a triggered update, it will do a calculation, finding out the next best way to reach the destination, and it will share to the nearest routers. And in this case of BGP, it is the slowest routing protocol if you're comparing with the IGP. And it will not do much in a hurry. It will send a packets, it will check whether it is alive or not. In case if it is not alive, in case of any network failure, in case of any link failure, and it will do a calculation, but it is not in that much hurry. So I can say it is the slowest routing protocol. And it is mainly for the service providers as well as enterprise level of customers. So moreover, if you're looking at into an enterprise level of customers, this is how an enterprise level of customers connected. And you have a router, you have a head office router, and the head office router is connected to the branch offices, and it is connected to ISP. And these ISPs are connected to one or more ISPs. And ISP, how it routes? It routes through autonomous systems because of BGP. So what is the BGP advantage? So I'll say BGP is always making a redundancy connection to your network. So how it's redundant? You mean to say that you are connected to multiple routers and you are configuring a VRRP or HSRP for redundancy? I'll say no, it is not that case. In this case, I have connected only to one ISP. You just think about the internet. If internet want to reach you, the only one way to reach me is through ISP, that is Autonomous System 100. So how my BGP networks look like? And I'm saying this is not the case of BGP. BGP case is this. You have multiple ISPs and you advertise your network through an autonomous system so that from internet they have multiple ways to reach you. And if you are looking into BGP, this video series will help you to understand what is BGP. So before going to configuration, I would like to share some more on BGP. So about BGP, I can say it is working on TCP. It is working on TCP. So you know that RIP is working on UDP and OSPF and EIGRP, they all having their own protocols for communication. In the case of BGP, the communication is happening through TCP and specifically port number 179. So next is BGP update timings, and 5 second is the internal BGP update timing and 30 second is the external BGP update timing. We will have a clear-cut look into internal BGP and external BGP from upcoming slides. So it having a complicated matrix calculation. Till now, we all know that EIGRP having a complex matrix calculation. And now that credits goes to BGP, and BGP having a complicated matrix and it having many attributes. There are 13 attributes. There are 13 factors to find the best way. And all neighbor relationship will not form automatically, and you have to go and manually configure the neighbor relationship. Now we can see how neighbor relationship forming in BGP. In BGP case, no auto discover. We all need to go and configure manually in the routers to form neighbor relationship. And neighbor relationship forms on TCP port number 179. In the case of OSPF, we will go here and enable OSPF, give a network command. We'll go here and enable OSPF, give a network command. It will automatically discover the neighbors and it automatically start sharing the updates. In the case of BGP, you have to go here and tell your neighbor is this one. Then only it will make neighbor relationship. So keep in mind, there is no auto discovery here. You have to manually configure the neighbors. And all this communication is happening on TCP number 179. In the case of BGP, there are 4 different packets. One is open, another one is update, keep alive, and notification. The open message which BGP routers are using for making a neighbor relationship. And update packets is moreover for sharing the routing updates. The keep alive, as name itself mentioning, it is just checking whether the neighbor is alive or not. And the notification, it's mainly for the changes of network, it's mainly for the failure of links, and it is mainly for the alerts which both the routers need to share. So these are the 4 different types of packets available in a BGP communication. And there are 5 different BGP router states: ideal, active, open sent, open confirm, and established. Ideal state, it's actually as equal as no action taking place. And the active states, and somewhere like there are 2 routers and one router you enabled BGP and you given the neighbor as the next router, but in the other router there is no BGP configured, and router number 1 is keep on trying to make a neighbor relationship, but it is not happening. And those cases and all, it is in active state. And there are some cases 179 port, TCP port disabled at the other end. So those cases also, from one BGP router cannot establish a neighbor relationship with other because of there is no smooth path. So those cases and all, this state will become active. Open send, it send the open message to the neighbor, and the open confirm. A neighbor also confirm. A neighbor also agreed all your agreements, and it is in a position to make the neighbor relationship, and at last the state is established. That is neighbor relationship form, and we are going to send the routing updates. So these are the 5 different states in BGP. This is the Cisco Packet Tracer Simulator, which I am demonstrating. So before going into in-depth of ISP network, we need a clarification why we need BGP and why we don't want to run BGP on our network. So why we need BGP? If you have extremely large network, or if you are a service provider, and definitely you will go for BGP. Or if your network need a redundancy path from internet, you will go for BGP. Why they are not going for BGP is many factors. You need redundant connectivity to different ISPs, and you need a routers which can run BGP, because internet means it having lakhs of network, and there are lakhs of updates. So you need a router which can handle entire traffic, which can handle entire updates. So these are the 2 factors which normally a customer is not going for a BGP. So in this case, there are 2 ISPs. One is AS200 and another one is AS100. And AS200 having a network 12.x.x.x and AS100 having a network 2.x.x.x. So if you have 2 different ASP, and if these 2 ASPs are connecting each other, so here we will use external BGP. This router to this router, router number 3 and router number 5, we will use external BGP connection. And this router will share entire routing information to router number 3, and router number 3 will share entire routing information to router number 5. If you're looking into one ISP may spread across a country, or ISP may spread across the globe. So there are different customers and customers connected to ISP routers. I can say there will be multiple customers who is connecting to router number 4, and they also need to know. That means the router number 4 also need to know about the internet traffic, and router number 4 also need to know about the entire routes. So from router number 3 to router number 5, we are connecting 2 different ISPs, and in this case we are using external BGP. And these routes which router number 3 learned from different ISP need to share to our routers. So for that connectivity, we will use internal BGP. So there are 2 BGPs. One is external BGP, another one is internal BGP. For connecting ISPs each other, or connecting to different autonomous systems, we are using external BGP. And the routes learned from external BGP need to share to our internal routers. For that purpose, we will use internal BGP. And this is the last slide. Time for recollecting. We started this discussion with IGP and EGP. RIP, OSPF, EIGRP, all it's coming under IGP. And the only one protocol which is coming under EGP is BGP. And then we have discussed what is autonomous systems and how the routes are sharing in between autonomous systems. And we had a look into an enterprise level network, and we had a look into ISP network, and we had discussion why we need BGP and why we don't want BGP. And highlighting point here, if you need a redundant connectivity from internet, go for BGP. Then we had a discussion on different types of packets available in BGP, that is open, update, keep alive, and notification. Then different states of BGP router, ideal, active, open sent, open confirm, and established. And then we had a discussion about what is ebgp and what is ibgp. In short notes, the connection between 2 autonomous systems, it will happen through ebgp, and the learned routes from different autonomous system and sharing to our internal routers will happen through ibgp. We'll see in the next video, and I strongly believe that this video will be helpful for you, and I would like to thank you for watching. Ideal, ideal state, ideal, ideal state,